Now, after you've done your division, you can write your answer as a division statement. So on the next page here, they have a division statement. They have it written out. I think it's easier to see if we use an example. So if we go back to example number 1 and the answer that we got, I'll show you what the division statement looks like. So the division statement says, well, what did we just do? We took 2x cubed plus 3x squared minus 2x plus 5. We divided it by x minus 1, and we got this as an answer, remainder 8. Okay? Off to the side here, I'm going to do something similar with numbers first. Okay? Let's say you wanted to take 25 and divide it by 7. You would get 3 is 21, remainder 4. So there's long division with a really simple number. The division statement is saying that, what does this mean? This means that 25, which is the number I started with, is equal to 3 times 7, but there's a remainder of 4, so I'd have to add that on to make it work. Does that look correct? So in our original equation, we're going to give these things names. We're going to give this initial big thing that we have inside here, we're going to call that our polynomial, p of x. We're going to call what we're dividing by our divisor. I'll use the letter d. Our answer, when you're dividing, an answer to a dividing question is called a quotient. So we're going to use q for that, and we're going to use r for a remainder. So in our example with numbers, this would have been our polynomial. This is what we're dividing by. This was our quotient plus our remainder. I like it because it makes me think of ice cream. DQ. So if I was writing my division statement for this question that we just did, we would say our polynomial is 2x cubed plus 3x squared minus 2x plus 5. That was our original polynomial, equals our divisor, x minus 1, times by our quotient, which we got 2x squared plus 5x plus 3, and then we have a remainder of 8. So this is our polynomial, dq plus our remainder. And if you ever want to check to make sure that your answer is right, you could multiply this side out, and it should match with what your polynomial was originally. So now that we know what a division statement is, let's go to example number 2. And not only are we going to divide this, but we're also going to write the division statement. Now, in example number 1 taught us one important thing for long division. The order is important. You have to start with your highest power and go down to your lowest power. Example number 2 shows us another important thing. Not only do we have to start with our highest power first and go down, example number 2 also shows us what do we do when a power is missing. Notice that there's no x squared here. We have to have a space for every power. Just like in numbers, even though, 5,035, the 0 that's there says there's no hundreds. There's 5,000s, 0 hundreds, 3 tens, and 4 ones. But we still need to write a 0 there. Just because there's no hundreds, we can't just say 535, because that would mean something else. With long division, with polynomials, if you're missing a power, notice there's no x squared, you still have to write it in with a 0. So the order matters, and if things are missing, we need to make sure that we have zeros in for them as well. We're dividing by x plus 2. And what do we get? Well, we look at our first number, 3x to the 4. What would I have to multiply x by to get that? A 3x cubed. I'm going to let you finish it off from here, and I'll put the answer up in a bit. So as you're working through it, you can check up above to make sure that your answers match. We should have got a remainder of 30 in the end. So if you got a different remainder, see if you can find out where you made an arithmetic mistake. Again, hardest place is with that subtracting. Sometimes you'll get the signs wrong, and it's easy to do. And now we can write our division statement. 3x to the 4 minus x cubed. In your division statement, you don't need to include the zeros. There's our polynomial. We are dividing by x plus 2. And we got 3x cubed minus 7x squared plus 14x minus 25 with a remainder of 30 in the end. This was our polynomial. Divisor, quotient, plus our remainder. Okay, questions you can do for practice on this one are 3b and 7. So we're going to take some time to do the ones for example 1 and example 2.